Anesthesia machine. In this class, we will be discussing anesthesia machine. Anesthesia machine has two components, electrical and pneumatic. What is the meaning of pneumatic? Pneumatic is use of gas or pressurized air in mechanical system. So first we will cover electrical components. What are the electrical components of anesthesia machine? We have master switch, which has both pneumatic component as well as electrical component. We have power failure indicator. It can be visual or audible. Then we have reserve power such as batteries. Then we have electrical outlets. Electrical outlets are for monitor or ventilator and data communication ports. So this is the electrical part of machine. Then we have the main part, which is the pneumatic part. Pneumatic part has been divided into high pressure system, intermediate pressure system and low pressure system. So just of these pressure systems, high pressure system receives gas from cylinders at a very high and variable pressure, and which is converted into lower, more constant pressure. So high pressure system, as we said, receives gas from cylinders. So oxygen cylinder has a pressure of 1900 psig and nitrous oxide cylinder has a pressure of 745 psig. Talking about intermediate pressure system, it receives gases from pipelines and has a pressure of around 50 to 55 psig. Low pressure system has pressure slightly higher than atmospheric pressure and it is variable. So this is a gist of all the three pressure systems. We will be discussing components of each pressure system. High pressure system receives gases from cylinders and cylinders are attached to the machine through hanger yoke assembly. Hanger yoke assembly is a part of high pressure system. We have unidirectional check valve, we have pressure gauge and pressure regulator. In intermediate pressure system, we have pneumatic part of master switch. Master switch has both the components. It has pneumatic part and electrical part. So pneumatic part comes under intermediate pressure system. Then we have pipeline inlet connection, pipeline pressure gauges, oxygen pressure failure devices, safety feature. Then we have, in newer machines, we have gas selector switch. Gas selector switch selects between air or nitrous oxide. Then we have second stage pressure regulator. Oxygen flush comes in intermediate pressure system. Then we have flow adjustment control and alternative oxygen control. All these components will be discussed. Then we have low pressure system. Low pressure system includes flow meters, vaporizers, unidirectional check valve, pressure relief valve and common gas outlet. So in this class, we will be discussing high pressure system and its safety features. This is a simple diagram, schematic diagram of anesthesia machine, and we have cylinders, oxygen cylinder, nitrous oxide cylinder with a unidirectional check valve, pressure gauge and pressure regulator. Up till here it is high pressure system. From here we have intermediate pressure system consisting of pipeline inlet connections, oxygen and nitrous oxide with unidirectional check valves, pressure gauge and pressure regulators. Then we have oxygen pressure failure devices, oxygen flush opening to common gas outlet, and we have flow control, flow adjustment control knobs. Up till here we have intermediate pressure system. Flow meters, vaporizer, common gas outlet, there is a pressure relief device. All these come under low pressure system. Flow meter, vaporizer, common gas outlet, pressure relief device comes under low pressure system. There is another diagram from DOSH. This is a bit more less simple. So we will be discussing each of the component here. This signifies cylinders. We have oxygen cylinders, nitrous oxide cylinders, air cylinder. We have filter. This cross signifies filter, and then we have unidirectional check valve. These are the check valves. Then we have pressure gauges in each cylinder to measure the pressure, and we have primary pressure regulator. We have secondary pressure regulator as well, but in high pressure system we have primary pressure regulators, which convert high and variable pressure from the cylinder to a lower, more constant pressure. So all this comes under high pressure system. After pressure regulator, we have intermediate pressure system. Intermediate pressure system includes pipeline inlet connections. This is of oxygen, green color. This is of nitrous oxide, and this is of air. So each pipeline is followed by a filter, unidirectional check valve, pressure gauge. Filter, unidirectional check valve, pressure gauge. Filter, unidirectional check valve, pressure gauge. Each pipeline also has a pressure relief device. In high pressure system, oxygen, each cylinder has a pressure relief device. So that is why we do not have a pressure relief device indicated in this diagram, because cylinder has a pressure relief device. Here in pipeline, this is the pressure relief device. This is in oxygen. This is followed by a gas power outlet, which can be an alternate oxygen gas outlet. Then we have 2 is oxygen flush, which opens into the common gas outlet. Then we have 3 is oxygen pressure failure devices, which are linked with other gases such as nitrous oxide and air. And we have an outlet for atmosphere. We can connect Bain's circuit to this outlet. Then we have secondary stage pressure regulators and filters. Then we have flow adjustment control knobs for each gas. Up till here, this is intermediate pressure system. Then we have an auxiliary flow meter and flow control knob for that as well. From here on, we have low pressure system. Low pressure system includes flow meters. Flow meters are arranged oxygen most distal towards the patient, and then the other gases, nitrous oxide and air, which is followed by vaporizers. Vaporizers are followed by a common gas outlet. Oxygen flush opens here, and we have a pressure relief device here as well with unidirectional check valve. So this is a diagram for overview of machine. Then we will be discussing high pressure system. High pressure system receives gases from cylinders. Cylinders have high and variable pressure, and they are attached to the machine using hanger yoke assembly. And we have another component, unidirectional check valve, followed by pressure gauge and pressure regulator. A little about cylinder parts. So cylinder has a body, which is the main part of the cylinder, with a valve. Valve is used to put gas inside the cylinder and vent out gases from the cylinder. So valve helps in filling cylinders and emptying cylinders. Then we have port. Port is the part of cylinder from where gas enters the machine. Port communicates with the nipple of hanger yoke assembly, from where the gas enters the machine. Then we have stem. Stem rotates. Stem helps in opening of the cylinder, and cylinder is opened using handle or key. Then we have pressure relief device. As we have discussed earlier, pressure relief device in case of increased pressures to vent out pressure into the atmosphere. So now high pressure system. hanger yoke assembly. Hanger yoke assembly helps in attaching cylinder to the machine. So it orients position of cylinder, it supports position of cylinder, provides a gas tight seal, also known as Budok seal, and provides a unidirectional flow. There are many parts of hanger yoke assembly. We have body, we have retaining screw, nipple, pin index, washer, filter. So body. Body is the main integral part of hanger yoke assembly. It is embedded inside the machine. It is embedded inside the machine. Only distal part is visible. It contains a retaining screw. Retaining screw is there is a conical depression on the cylinder. There is a conical depression on the cylinder which fits on the retaining screw. Then we have nipple. In this diagram, as you can see, there is a nipple in the center of this. Nipple communicates with the port. Port is where the exit of gas occurs. So nipple communicates with the port. Then we have pin index. Pin index is for safety. So in order to prevent incorrect positioning of cylinders, we have pin index. We have washer to provide leakless flows. Neoprene washer is used with copper ring and it is non-combustible. Filters are to filter out any debris which can cause fire. So these are the diagrams showing hanger yoke assembly. We have washer, black colored. We have retaining screw and we have nipple inside this. This is the pin index, different pin index for different gases, and this is another diagram showing nipple, retaining screw, washer, pin index. Then we have check valve. After hanger yoke assembly, we have a check valve. Hanger yoke assembly is followed by a check valve which prevents prevents gas from exiting when there is no cylinder on the yoke. Suppose the hanger yoke assembly is empty, there is no cylinder. So suppose the hanger yoke assembly is empty, there is no cylinder. What we can do is we can use a yoke plug. Yoke plug mimics the part of cylinder and attaches to the hanger yoke assembly to prevent leakage. So another safety feature is check valve which prevents gas from exiting when there is no cylinder on the yoke. This is a diagram showing check valve. There is an inlet followed by an outlet. So there are valves. Valves prevent the flow of gases in opposite direction. So that is why they are unidirectional check valves. So it prevents flow of gases from other cylinders. Other cylinders, suppose one cylinder has higher pressure and the cylinder has lower pressure. So gas will flow from lower pressure to a higher pressure, which is avoided by unidirectional check valve. Or gases can flow from intermediate pressure system which has lower pressure as compared to high pressure system. And this can be done while exchanging full cylinder. Suppose we are exchanging a full cylinder with an empty one. While exchanging, the hanger yoke assembly will be empty, and this can lead to backflow of gases from intermediate pressure system to outside or a high pressure cylinder to a low pressure cylinder. A yoke should not be left vacant. We have to use yoke plug. We have to use yoke plug if cylinder is not available. If one cylinder of a gas, if there are two sides for oxygen cylinder, one cylinder of a gas should be open at a time. While placing cylinders, we have to keep in mind that we have to wash our hands. There should be no oil or grease, as the process of opening of cylinder is adiabatic. There can be chances of fire. To avoid that, hands should be clean, surface should be clean, there should not be any oil or grease, and we have to match the pin index in order to avoid placement of incorrect cylinders. So we have discussed hanger yoke, we have discussed check valve. The third part is cylinder pressure gauge. Cylinder pressure gauge or cylinder pressure indicator. It tells about the pressure. It is of type Borden spring type or Borden tube type. These are the diagrams showing display of pressure gauges on the machine. So Borden spring type is, we'll discuss it here. So what happens is there are three parts. There is a coiled tube. This is a coiled tube. It has a open end. This is the open end. It has a sealed end. This is the sealed end. The sealed end is connected to, in a mechanical system, to a pointer. Through mechanical system, it is connected to a pointer. Pointer moves on a calibrated dial. So there are three things we have to remember. One is a coiled tube. Coiled tube has an open end and a sealed end. There is a pointer which is attached to a sealed end. And then we have a calibrated dial. So what happens is when gas is opened, it will travel through this coiled tube. Due to pressure, this coiled tube will straighten out. It will slightly straighten. Straightening of coiled tube will make the pointer move, and it moves on the calibrated dial, and this movement shows the pressure. More the pressure, more the straightening of coil tube, more is the pressure shown on the calibrated dial. This is the principle of Borden pressure gauge or Borden spring tube pressure gauge. More the pressure, more the straightening of coil tube, and more the pointer moves on the calibrated dial. So we have discussed cylinder pressure gauge. Now the pressure regulator. Pressure regulator, it regulates the pressure. High and variable pressure from the cylinder is converted to a lower, more constant pressure, and it is lower than the pipeline. So that pipeline remains the main supply of gases for anesthesia practices. That is why pressure regulator lowers the pressure, and it is lower than the pipeline system. The principle, this is a diagram showing pressure regulator, schematic diagram, and the concept behind pressure regulator is pressure is equal to force upon area. Keeping the force constant, if the force remains constant, we will have pressure into area as constant. Pressure into area will be pressure into area P1 V1 A1 P1 A1 will be proportional to P2 A2. So this concept is used. Pressure is equal to force upon area. Keeping force constant, we will have P1 A1 equal to P2 A2 as force is constant. So what happens is we have a high pressure inlet. This high pressure inlet opens into an area which has a larger area. So this area decides the lowering of pressure. High pressure gets distributed into a larger area, converting into low pressure. So diaphragm area decides the output pressure. P1 A1 is equal to P2 A2. So depending upon the diaphragm area, the output pressure will be decided. High pressure enters from here, it is distributed into this diaphragm area, which increase in area decreases the pressure. As pressure is inversely proportional to area, increase in area decreases the pressure, and further we have an output of low pressure. This is the schematic diagram showing function of pressure regulator. Works on the principle pressure is equal to force upon area. Force remains constant. So, force remains constant. So, P1 A1 is equal to P2 A2. Then we will be discussing the safety features. Safety features of high pressure system. In this class, we have not covered details about cylinder, which will be covered in another class. The safety features of high pressure system includes safety features about cylinder. So, color coding is a safety feature. We have oxygen cylinder with black body and white shoulders. We have air cylinders with black body with white and black shoulders. We have nitrous oxide cylinders with blue body and blue shoulders. We have Antonox cylinders with white body with blue and white shoulders. We have carbon dioxide cylinders with grey body and grey shoulders. We have helium cylinders with brown body and brown shoulders. So one is color coding. One is color coding. Next safety feature is pin index. Pin index is a safety feature in which there is positioning of pins. This is the port and pins are placed like this in an arc with a radius of around 9 by 16 inch. Suppose this is the port, this is the arc, this radius is 9 by 16 inch. Dimension of each pin is 6 mm by 4 mm, and only pin number 7 is slightly thicker. So pins are arranged, this is the port, pins are arranged 1, 2, 3, 4, 5, 6 and 7, and 7 is slightly not in the arch and thicker. So air has a pin index of 1.5, oxygen has a pin index of 2.5, nitrous oxide has a pin index of 3.5. Then we have a diagram, we have discussed it earlier. See, this is the pin index, this is the port, this will be 9 by 16 inch radius, and each pin has a dimension of 4 by 6 mm, 4 mm by 6 mm, and placements will be like this. You can see 1, 2, 3, 4, 5, 6. So, and 7 comes in the center. So, pin index. We can use this as AON 15, 25, 35. Okay. Air, oxygen, nitrous oxide 15, 25, 35. Then other safety features include there is labeling of the cylinder, there are markings imprinted on the cylinder, date of expiry, date of filling, pressure, and we have cylinder pressure regulator, which works on the same principle as we have discussed it here, with the pressure is equal to force upon area, force keeping constant. Then we have pressure relief devices. Pressure relief devices, what they do is they vent out extra pressures, extra gases into the atmosphere to prevent blasts of cylinder due to sudden increases in pressure, which can be due to sudden increases in temperature or any other reasons. So the basic diagram of pressure relief device is here. We have a safety valve and we have a discharge channel. These are the discharge channels. this is the body, safety valve body. There is a spring, this is the spring. So what happens is, if the pressure increases, this pushes the safety valve inside, compresses the spring, and the gases can vent out through these discharge channels. Then we have other types of pressure relief devices as well. We have fusible plug, we have rupture disc. Fusible plug senses temperature, rupture disc senses pressure. So what happens is, increase in temperature or increase in pressure leads to breakage of the disc, which leads to opening of the discharge channel. This is the basic concept. So this is another diagram showing cylinder valve through which cylinder is opened, stem, then we have port, then we have pin index 1, 2, 3, 4, 5, 6 and 7 is in the middle, and this radius is 9 by 16 inches. Each pin has 4 mm by 6 mm of dimension. Then this is the threading neck of cylinder, and then we have body of cylinder. This is the hanger yoke assembly showing Bodox seal and port, nipple, and this is the pins. Then we have air, oxygen, nitrous oxide 1,5, 2,5, 3,5. Carbon dioxide is 1,6, and NOx is 1,7.